All passengers landed safely with their parachutes.
You know, it's a thought that I think has crossed just about everybody's mind at some point. You're cruising at 35,000 feet, you hit a bit of turbulence, and that little question pops into your head. Where are the parachutes? It feels like it should be there, right? But, as we're about to find out, the real reason they're missing is way more fascinating than you'd think.
I mean, it just makes sense, doesn't it? Boats have life rafts, planes should have parachutes. It feels like this fundamental piece of safety gear that's just not there. But is the answer really that simple? Well, that's where our intuition kind of smacks right into the wall of, well, physics, engineering, and just plain old human psychology. The truth is, putting parachutes on a commercial plane wouldn't just not make you safer, it would almost certainly do the exact opposite. So let's break down why.
Okay, so let's just play this out for a second. Imagine there's a serious emergency, and you hear the captain's voice come over the speaker. All right, everyone, time to bail out. What do you think happens next? Because it's a scene straight out of a movie, but the reality is an absolute nightmare.
First off, you've got hundreds of panicked passengers trying to figure out how to strap on a bulky parachute they've never even seen before. It takes trained skydivers minutes to gear up properly. Now let's talk about that door. You can't just open it. The pressure difference is so huge, it's like trying to push against the weight of a car. But even if by some miracle you got it open, you'd then have to jump out without hitting a wing or getting sucked into a jet engine. It's a total non-starter. But okay, let's say, against all odds, you actually make it out the door. You've somehow managed the impossible. Congratulations. You've just entered one of the most hostile environments on the entire planet. The second you leave that plane, you're not gently floating. You hit a wall of wind, moving at almost the speed of sound. The sheer force of that impact would be catastrophic. We're talking like hitting a brick wall at over 500 miles per hour. And remember where you are. You're at 35,000 feet. The air up there is so thin, you literally can't breathe. You would pass out from lack of oxygen in a matter of seconds. And no, your parachute doesn't come with an oxygen tank. And if all that wasn't enough, then you've got the cold. A completely brutal minus 60 degrees Fahrenheit. We're talking instant frostbite. So even if you survive the exit and somehow find a way to breathe, you're still in a literally cold environment. The odds are just stacked against you in every conceivable way.
So bailing out is clearly a non-starter for passengers. We get it. But what about the plane itself? Why not just add the parachutes anyway, just in case? Well, this is where we run into the third massive problem: the incredible, crushing burden of weight.
There's this amazing quote from a classic aerodynamics textbook, and it perfectly explains this idea of a cascading weight penalty. In the world of aviation, weight is everything, and every single pound you add to a plane has this massive ripple effect on the entire design. So think about it. You add 200 parachutes. That's not just a few hundred pounds. To carry that extra weight, you need more fuel. To carry that extra fuel, you need bigger fuel tanks. To lift all that, you need bigger, more powerful engines. And to support those engines, you need a stronger, heavier structure for the plane itself. It's a cycle that just makes the whole thing incredibly inefficient and impractical to fly.
All right, so if parachutes are out, what's the real safety plan? This is where we have to totally reframe the question. You see, we've been looking for a lifeboat, but the secret is we're already in one.
You see, a huge airliner, even with no engine power at all, doesn't just drop out of the sky like a rock. No way. It actually becomes a surprisingly good glider. A pilot can fly that plane for 100 miles or even more, which gives them plenty of time to communicate, find an airport, and bring it down for a safe landing. That ability to glide is probably the most important safety feature built right into the plane.
And layered on top of that, you've got this principle of redundancy. Modern planes are built with what's called a fail-safe philosophy. That means every single critical system has a backup. And sometimes that backup has a backup. The entire aircraft is this incredible web of redundant systems designed to make sure that if one little thing goes wrong, something else is ready to take over instantly.
But maybe the most important safety feature of all is just what we've learned over the years, often from tragedy. Take the de Havilland Comet. Back in the 50s, it was the first jetliner, but they started falling apart in midair. Turns out, the cause was the square windows. Those sharp corners were creating stress points that led to the plane just breaking up. The solution? Rounded windows. Just think about that. That one tiny design change, learned the hard way, made every single plane safer from that day forward. Get this. A modern airliner has something like 4 million individual parts, and every single one of them, every bolt, every wire, every panel, has been designed, tested, and certified to meet the most insane safety standards you can imagine. The entire focus isn't on how to escape the plane, it's on making sure you never, ever have a reason to.
So, when you put all of this together, the physics, the engineering, the history, you come to this really simple but powerful conclusion. The safest, most reliable, and most effective parachute you could ever have on a commercial flight is the airplane you're sitting in.
It really changes how you look at it, right? The solution was never about finding a way out. It's about trusting the incredible amount of science and engineering that went into making sure you'll never need one. You're not flying in a machine that needs a backup plan. You are flying inside the backup plan.